In today's video, we will have a look at how to properly set the size and position of the print area of our 3D printer. But before we start, I would like to thank everyone who decided to support the existence of this YouTube channel. I would also like to thank all those who have decided to become my Patreon, to support my work and to ensure the future of this YouTube channel. If you want to be one of them, you can do so on the links in the description below the video. Many printer users make the same mistake when uploading new firmware. They copy the sample configuration and they upload it to their 3D printer without any check. Did you ever get something to print on the center of the bed, but the print was not in the center of the print bed? This was probably because you did not correctly specify the size and position of the print area. When we find information about the print bed in this configuration, we learn that according to this configuration, our print area is 235mm on the x-axis, 235mm on the y-axis, and can be printed up to 250mm high. At the same time, we have said that our print bed is at position 0 on the x-axis, at position 0 on the y-axis, and at position 0 on the z-axis. In other words, after homing, our nozzle should be on the left front corner of our print bed and even touch our print bed. But as we can see, it is not. We will ignore the minimum z-axis position in this video. How to set up this position and calibrate our bed, we are talking in the video about print bed calibration. We will focus only on the size and position of the print bed on the x and y axis, and on the maximum height of the printed object. The first thing we do is turn off the software end stops. These limit the movement of axes outside the defined area, thereby protecting our printer from possible damage. But how to turn these end stops off? By the documentation, all you need to do is submit the M211S0 command to the printer. We can do it in more ways, but just like in the previous videos, also in this one, we will choose the simplest method for us. The easiest way is to create a text file, write M211S0 into it, and save it as disable end stops G-code. Save this file to your printer's memory card and then start printing in the printer. As first, we home the printer and turn off the software end stops. Now when we look at the nozzle, we will see that it is outside the print bed. We will begin the search with the axis that is not on the print bed. If the nozzle is completely outside the print bed, we begin with the y-axis. Just to be sure, we jump up with the z-axis by 1 mm. Now we try to move the y-axis and find the position where the nozzle is safely located above the print bed. We moved the y-axis by 6 mm and our nozzle is safely above the print bed. So we will write to our firmware that the y-min position is 6 mm outside our print bed. Now we look at the x-axis. As you can see, on the x-axis, we are already above the print bed. So we measure this distance and write it to our firmware as x-min pos. In my case, the nozzle is 3 mm on the print bed. When you have this data written in our firmware, click the build button to make sure there is no error. We have an error. I didn't expect that. The reason for this is that the axis dimensions were recalculated during the build and the print bed overlaps with the new data. So let's set, just for now, an absolutely large number to x-max position and y-max position. Upload the firmware to the printer and let's continue. As you may notice, after the firmware has been updated, the printer displays the home position we have changed. Unless we home the printer doesn't know what is the real current position. So the printer thinks the current position is the home position. After the firmware has been updated, home the printer. After homing, turn off end stops. Move the nozzle on the Z-axis 1 mm away from the print bed. Move the nozzle to the new 0 position on the Y-axis and let's focus on the X-axis. Now we can try to measure the actual size of our print bed on the X-axis. Slowly move the nozzle to the right edge of our print bed, and during this movement, we check that the nozzle is not out of bed on the Y-axis. If this happens, we would have to change our home Y-axis position in the firmware and update the firmware again. Or we can solve this problem in another way. Marlin has a section where you can set skew compensation to fix this problem. We will look into this in the detail in one of the next videos. Now a demonstration of how this compensation works in reality. For example, the Prusa E3 printer has been able to detect this skew since Mark II and calculate the compensation for us. Using its calibration probe, it detects 9 calibration points on the print bed and creates a map of their locations. During printing, it calculates the difference to compensate for the skew. As a result, for example, when the X-axis is moved, the printer does not only move the X-axis, and the same is during the move of the Y-axis. Instead, the printer moves both axes simultaneously. Thanks to this correction, our printed object retains the right angle and the skew is not known at all. You can find out more about it on the link in the description below the video. Now back to our calibration. As you can see, the nozzle is still above the print bed and we are at the end of the bed on the X-axis. So let's take the current position of the X-axis and write it to the X bed size. We still stay on the X-axis and measure the actual length of our X-axis. We will continue to move slowly on the X-axis and take great care not to damage anything and do not hit anything. Let's take this value and write it to X max pos. Now we go back to the corner of the print bed and repeat the process, this time for the Y-axis. We start with the print bed size on the Y-axis. We will slowly move the bed forward. During the move, we are again careful not to damage anything and do not hit anything. Let's take this value and write it to Y bed size. Now, let's move the nozzle to the beginning of the X-axis just to check that our print bed size on the Y-axis is safe and we won't be printing outside the print bed. Now you have to find the end of the Y-axis. From this point of view, it seems that we can still move a few millimeters, but we must pay attention to both sides of this axis. Now, take the current value and write it to Y max pos. When we are done, we'll try to find a limit of the Z-axis. All we need to do is move the Z-axis as far as possible. But again, we will keep some space. Let's put the value into our firmware. Now, update the firmware in our 3D printer. Last but not least, remember to update the values in your slicer. If you have a print bed attached with help of something that interferes with your print area, be sure to count on this during this process as well.